Hey guys, hope things are going well. Today I want to show you how to do correlation using Excel. I'm going to use the built-in functions of Excel, the Data Analysis Tookpak, and I'm going to show you the Correlation and SLR file, which is in blue in your supplementary files folder, and that's one that you can use for your project. So let's take a look here. Here's the height and weight example from Unit C. And by the way, if you have to check your numbers, remember I showed you the very first row here of the x, the y, the x squared, the y squared, and the xy, and the totals at the bottom. But if you're not getting the same numbers, here's the answers down here. Anyways, I'm going to ignore that and show you how to actually do this using Excel. It's really simple to use the CORREL function in Excel to calculate a correlation. So this is the way that we do this. We go up here to Formulas, More Functions, Statistical, and somewhere down here you'll find the CORREL function, CORREL or correlation. There's also a Pearson's one which does exactly the same thing. Now, your dialog box might look a little bit differently, but basically it's you choose your X's without the titles, you choose your Y's without the title. So in my case then A2 to A11 and B2 to B11, and you press done, and that's it. That's all you need to do. So I'm just going to copy that there. And I'll paste it over here. Put an apostrophe in front of it, and there's your function. I guess I need to get rid of this guy here. And of course you can take that down to a couple 3 decimal places, and that's what we got in class when we did this by hand. So that's how you use the CORREL function. I want to show you another really interesting one when we get into multiple regression and we want to calculate a bunch of Pearson R's. So right now we only have one X and one Y, so there's only one Pearson R. But if we had a number of variables, then we could take a look at the R's between each pair. So what I've done here is I've pulled up the, let's see, the Stats 101, and I've gotten rid of most of the variables. So I've only kept the interval scale variables, the GPA, age, Math 30, and English 30. Let me show you how we can calculate what we call a correlation matrix in Excel. We go up to the Data menu, and over at the right, we've got here Data Analysis. And again, I'm using a Mac here, so yours might look a little bit different. And you may have to add that in, of course. But it's the same old list of different kinds of functions that we have, procedures as before. Here's all your t-tests and things, your descriptive stats up there. And there's the ANOVA, and here is correlation. Now this is super simple. What you do is you just highlight the titles and all of the values that you want to calculate correlations for. So all the way down. Of course, I'm not doing the respondent column. Tell that you got labels in the first row. And then I'm going to choose an output range. And that's it. You press OK. And what you get here is these are all the Pearson R's. That's the correlation coefficients, the Pearson R's, the little r's between every pairing of variables. I'm just going to take these down to a couple 3 decimal places. There we go, like that. So what this is saying then is that Math 30 and GPA are fairly highly correlated. They have a 0.6 correlation between them. English 30 isn't far behind, and age is third on the list. It doesn't matter whether it's positive or negative. You can have a strong negative correlation. Remember, the closer you are to plus or minus 1 indicates the strength of the relationship, not the sign. But look over here. We've also got a very strong relationship between English 30 and Math 30. That's going to come in later when we take a look at something called stepwise regression and multicollinearity. But that's in Unit M. So we're just going to tuck that away for now. Anyways, that's how you come up with a correlation matrix here that shows all the Pearson R's, little r's, between every pairing of variables. Last thing I want to show you here is how to use this correlation template. So I've actually pulled over the 2 pages that I need and put them into this file. But this comes from the Correlation and SLR template, which is one of the blue text files, which is found in supplementary files in Blackboard. And this is a useful thing for you to use here. So I'm going to go back here to the height and weight example. And what I'm going to do is just highlight, including the labels at the top there, the heights and the weights. And I'm just going to copy them. I'm going to move over to that particular document, or in this case, I've copied the pages over. And I'm going to paste them, including the titles, right here. I'll just paste the values like that. Now, in our particular case, we had this as a one-sided test, upper tail, so you can change your HA right here. And take a look at what we've got. Here's the R that we calculated by hand. Here's your N, your critical value, 5.70, alpha 5%. Oh, sorry, that was the T star value, calculated value. Here's your critical value. And here's your p-value. And you would be rejecting HO. So here's all the different calculations that we did by hand. And then over here, I've got the Spearman's correlations. So this was the 0.88 that we calculated, the RS value and the T star, and so on like that. So that's what we had on page, what was that, C9, I think it was. Here's all of the ratings, the rankings that we have here. So we changed these original 56, 57, 60, 63, and so on into 1, 2, 3, 4, 5, 5, and so on like that. And then we had the y's, the differences squared, and here's your sum of the DI squares that goes into the formula there. I've got some regression output here as well, and this will be useful when we get into the next unit, but at this particular point you can ignore that. And so we'll keep that there. Now, how do you actually use this particular thing? Well, what you do is you copy your x's and y's onto this particular page, and then you go to the normality page, which has an Anderson-Darling test just like in ANOVA, and it does a normality test for the x's and another one for the y's. Now, is there a problem here? Well, if the n was at least 30, we wouldn't have to worry about what the conclusion is. In this case, the n is 10. Of course, they're going to both be the same because they're paired. And so we come down here, and it says do not reject HO for the x's, do not reject HO for the y's. HO is that they're normally distributed. So in other words, we do not have a violation of normality here, which means we don't have to use the Spearman's. If either of those showed a reject HO and the n was less than 30, then we would end up using the Spearman's instead of the Pearson's. Last thing I want to do is just go over and take a look at the age and push-ups example. So this is what we've got here. And again, if you missed any of the numbers when you were doing this by hand, here's a little table here of the x, the y's, the x squares, the y squares, and the x y's. So again, let's calculate a correlation. I'm just going to type in the CORREL function, so equals CORREL, and then I'm going to go up here and Here's my x's right there without the labels. And then here's my y's right there. And we end up with minus 0.631, which is what we calculated before. All right, let's go over here to the correlation page. I guess I need to get rid of these heights and weights here. Let me do that first. There we go. And let's go back to the push-ups, age and push-ups, and I'm going to grab these guys right here and copy them. And notice I've included the titles, and I'm going over here to correlation tests, and I'm going to paste them. Paste the values. Okay, so let's go to the normality page. Is there a problem? No. The n's are small, and so we need to look at the conclusions here. But for the x's, do not reject HO, do not reject HO. And so what we have here then is that we should be able to use then the Pearson's test instead of the Spearman's. I think for this one we also had this as a two-sided test, so I'm just going to change that. And these numbers here, let me make it a little bit bigger. These should match exactly what we got by hand. So there's your R, and there's your critical value right there. Here's your T star, and then we would reject HO. Here's the P value. If you were to do this as a Spearman's problem, and it might be good practice for you to do that to see if you get the same numbers, then this is what your RS would be, your T star, same critical value, and reject HO. Here's the rankings, so you can try this on your own, and so on. Here's your sum of the DI squares. They're really quite different from each other, aren't they? Yeah, but that's what happens when you end up with a negative correlation. All right, so I think that ends what I wanted to show you here about correlation. Thanks for listening.